Hello everyone, welcome to my channel. My name is Rohan PAWAR, studying in Sri Venkateshwar College of Engineering, Bangalore. I belong to the Department of Basic Science. My USN number is 1VE23CA037. Section name is DEVO. Course code is BCHES202. Subject name is Applied Chemistry for CSE stream. Today's my topic is about corrosion. Introduction to corrosion. Corrosion is a silent but destructive process that affects metal. It occurs when metal is exposed to an electrolyte and become a cathode and anode. In this presentation, we will explore the definition, types, causes, effective prevention, and control method of corrosion along with the real life case studies. Let's dive into the video. Definition of corrosion. Corrosion can be defined as the destructive or deterioration or loss of metal or alloy by the surrounding metals through chemical or electrochemical reaction. What happens in the corrosion in chemical reaction? During corrosion, metal atoms lose electron, leading to the release of metal ion. This process involves complex chemical reactions and can be accelerated by factors such as moisture and temperature. Fundamentals of corrosion. Corrosion is a natural process that converts a refined metal into a more chemical stable form. In corrosion, the metal acts as the anode and cathode in the electrochemical cell. Corrosion may occur either in dry environment or in an aqueous medium. This form is called as dry corrosion and the latter is called as wet corrosion. Dry corrosion, also known as chemical corrosion. Dry corrosion involves the direct attack of metal by dry gases, mainly through chemical reaction. It occurs by direct attacks of atmospheric gases such as oxygen, hydrogen sulfide, halogens and sulfur dioxide on the metal forming oxide layers. Example, the attack of dry air or oxygen on a metal to form an oxide layer over the surface. Wet corrosion, also known as electrochemical corrosion. Wet corrosion involves reaction in aqueous solution medium. The conducting surface of metal undergoes an electrochemical reaction with the moisture and oxygen in the atmosphere. Example, rusting of iron. Wet corrosion is explained on the basis of electrochemical theory. Types of corrosion. Galvanic corrosion, pitting corrosion, crevice corrosion. When two metals having different electrode potentials are in contact with each other in the presence of an electrolyte, one metal acts as cathode whereas the other acts as an anode. This leads to an electrochemical reaction as a result of which anode is dissolved into the electrolyte. Pitting corrosion. This type of corrosion is observed when dust particles or oil drops disposed over a metal surface. Pitting corrosion is due to metal surface is not homogeneous, external environment is not homogeneous. Corrosive corrosion is an localized act on a metal surface at or immediately adjacent to the gap or crevice between two joining surfaces when exposed to a strength electrolyte. Causes of corrosion. What are the causes of corrosion? Mainly moisture, oxygen, salt. Moisture effects. Water is one of the main sulfuric culprits in corrosion. It provides a conducive environment for chemical reaction to occur, accelerating the corrosion process. Oxygen. The presence of oxygen is crucial for the corrosion of most metal. It reacts with the metal atoms, initiating the corrosion process by forming metal oxides. Salt, especially in the form of salty water or salt leads air, significantly enhance corrosion due to its corrosive effects on metal. Effects of corrosion. Structural integrity. Corrosion can compromise the structural integrity of building, bridges and other infrastructure, leading to potential failure and safety hazards. Economic impact. The economic impact of corrosion is sustainable, leading to cost repair, downtime and replacement of metal assets. Implementing effective corrosion prevention measures can result in significant cost saving, etc. Environmental concerns. Corrosion is not only affects the structural integration of metals but also environmental implication. The release of metal ions and pollutants due to corrosion can impact ecosystem and human health. What are the prevention and control methods of corrosion? Preventing protective coating. Corrosion is prevented by application of protective coat on the surface of the metal. Thereby the metal surface is isolated from the corrosive environment. Important types of protective coating are metal coating and inorganic coating. Metal coating. The process of coating base metal with a layer of protective metal is all known as metal coating. Anodic coating, galvanization, cathodic coating, inorganic coating. These coatings are produced at the surface of the metal by chemical or electrochemical reaction, anodizing and phosphating. Prevention and control methods in cathodic protection. Cathodic protection is the technique of offering protection to a specimen against corrosion by providing electrons from an external source. There are two important methods of cathodic prevention: sacrificial anode method, impressed current voltage method. Design and material selection. Selecting corrosion resistant materials such as stainless steel or alloy can greatly reduce the susceptibility or structure of our equipment to corrosion. Case studies of corrosion: infrastructure, marine corrosion, automotive corrosion. Types of corrosion testing. Corrosion testing encompasses different methods of assess the corrosion resistance of material and structures. Some common types of corrosion testing includes accelerated corrosion testing, salt spray testing, electrochemical testing, immersion testing, cyclic corrosion testing. Conclusion of this video. Corrosion is a pervasive theory to metal acids, but with effective prevention and proactive measures, its detrimental effects can be mitigated. By understanding the mechanisms of corrosion and embracing innovative prevention techniques, we can ensure that the longevity and sustainability of metal surfaces. Thank you for watching my video. Please like this video.